Okay, so we're going to do the second half of lesson 4-3's homework, and this is problems number 15, 16, and 17 on page 199. So Jason is driving his car on a highway at a constant rate of 60 miles per hour when he passes his friend Alan, whose car is parked on the side of the road. So actually you're getting your first equation from here. Remember, probably back to Algebra 1, the formula that distance equals rate times time. So that means that Jason's distance equals 60 miles an hour times however much time he's on the road. So there's equation 1. Alan has been waiting for Jason to pass so that he can follow him to a nearby campground. To catch up to Jason's passing car, Alan accelerates at a constant rate. The distance, d in miles, that Alan's car travels is a function of time. Since Jason's car has passed, is given by this. So they gave us that second equation, which is d equals 3,600 t squared. Alan's car, find out how long it takes Alan's car to catch up to Jason's car. Well, since these are both equal to d, I can just take that 60t and substitute it in. So we've got 60t equals 3,600 t squared. And then I'm going to go ahead and divide by 60. So you get t equals, these are going to go to zeros, 6 goes into 360. 60 times. So you have 60t squared. And then I am going to, well, they did this word. Okay. I'm going to divide by t squared. So the t squareds go away. This here is, I can cancel one of these into here. So I would have 1 left on the bottom. So 1 over t doesn't really work for us, but I should have really done this a different way. Could have done it in fewer steps. I could cross multiply these guys. So I would end up with 60t equals 1. And then to get t by itself, divide by the 60. So t equals 1 over 60. And that's how much of an hour to catch up. So it takes 1 over 60th hours to catch up. And if you think about it, 1 over 60th hours is really just 1 minute. 1 minute is 1/60th of an hour. All right, in 16, we've got the flight of a cannonball towards a hill as described by this parabola. This hill slopes upward along this path. Where on the hill does the cannonball land? You'll notice, again, they're both equal to y, so I can take this one and substitute it into y in the other one. So 0.15x equals 2 plus 0.12x minus 0.02x squared. Switch my tablet here. Okay. So now I want to get this to the other side, so I'm going to subtract it over. And we get 0 equals 2 or minus 0.03x, oops, not plus, minus 0.002x squared. Fix that. All right, oops, sorry. Okay, this right here is, we're going to go ahead and use the quadratic formula to solve it because we definitely would not factor that. So I'm going to go x equals negative. My b value is this negative 0.03 plus or minus the square root of negative 0.03 squared minus 4 times 2 times negative 0.002 all over 2 times the 2a. At this point, I would put this all into my calculator. So let's go ahead and do that together and see what we get. And remember, we can't put in the plus minus. We only can put one of those at a time, but we're going to kind of try to take some shortcuts on it with the graphing calculator, okay? So let's see if my computer will catch up with me here. Oops. Not that button. Not that button either. There we go, end show. All right, so let's go over to the calculator, and you should be in the scratch pad. First thing I would do is add in a fraction, so I hit a control divide. And we're literally putting this all in at once. So 0.03, and I'm going to do the plus version first, so I need to hit a plus sign. Plus, and then I want my square root, control, and the squared button. And then the negative, I should really type that, negative, not answer, negative 0.03, ooh, I really needed that in parentheses, squared. And then minus 4, and then it's times negative 0.002 times 2. I think I may have done that in a different order. The book, I was just doing what the book had written in their answer key. And then it's over, I think I wrote it in the problems wrong. Let me go back and look real quick. Hang on. Ah! I mixed up my A and my C, didn't I? Look at this. Because it's in a different order. This is actually A and this is actually C. So this should have been, it really doesn't matter here because they just would have been a reversed location. But here it should have been negative 0.002 instead. So, typo. Not reading it right, going too fast. And then we've got 2 times negative 0.002. And then simply hit enter. And there's one of our answers is negative 40. And then I'm going to highlight this. Well, maybe. See if it lets me do it. There it goes. Okay, I'm going to highlight it. If I click on it enough times, I get the whole thing, and I hit Control C and copy it, so I don't have to type it in again. Go into my little cursor in my box and hit Control V, paste it, and then you can just grab this and go over the top of it with a minus sign, and then we get our other answer is 25. So let's write those two things down in our homework here. So we know that x equals negative 40 and x equals 25. So the thing is, though, that we're talking about a direction here, and we probably are not going to have a negative value when this happens. So really we just have the 25. But the 25 doesn't talk about where it lands. It's probably talking more about, it doesn't really give us a value for the x. The landing value is really what the y value is. That's our end value. This is where the two things cross, but it isn't where it actually lands. So when it, for the landing value, we're going to go back into this equation here and plug in the 25. So y equals 0.15 times 25. If we were to put that in our calculator, we get y equals 3.75. So basically, we did just solve the system. So it lands, so it gives us the coordinate where it lands. There we go. So it lands, so the cannonball lands, jumped. Cannonball lands at the coordinate 25, 3.75. All right. We've got Amy. She throws a quarter from atop of a building at the same time that a balloon is released from the ground. The equation describing the height y above the ground of the quarter in feet is this, where x is the time in seconds. The equation describing the elevation of the balloon in feet is this, where x is the time in seconds. After how many seconds, so I only have, notice, we need to know the seconds, which means we're only having to solve for the x value. We don't have to worry about the y value. Will the balloon and the quarter pass each other? Check your solution for reasonableness. So notice they're both equal to y, which means I can just take this one and substitute it into y in the other one. So essentially we're setting them equal to each other. So 6x plus 8 equals 64 minus 2x squared. All right, we've got a quadratic. That means we need to get it equal to 0 to solve it. Because this lead coefficient's negative and I don't like that, I'm going to start by adding that to the other side, which means I'm just writing it down because we don't have any other x squareds. We're dropping down the 6x because we don't have any more of those. I'm going to subtract the 64 over, and 8 minus 64 is negative 56. Okay, if I can factor out a greatest common factor, I do, and I've got a lead coefficient of 2 there, and they're all even, so I'm going to divide everything by 2, which is the same as factoring out by a greatest common factor of 2. So 6x divided by 2 is 3x, and 56 divided by 2 is 28. And then it looks like I've got a magic x problem. So I've got two numbers that multiply to negative 28 and add to 3. And I'm thinking 7 and negative 4. So I've got x plus 7 times x minus 4 equals 0. And we're going to use zero product property to split them up and set them both equal to 0. So x equals negative 7 and x equals positive 4. Now, it's time. We can't go backwards in time, so negative 7 is not a reasonable answer. So we could say the quarter and balloon pass each other at 4 seconds.